Alright, in our last class we got our first introduction to three-dimensional solid geometric figures, and we've talked a little bit about surface area. However, the main focus of our current unit, Unit 8, is volume. Okay, so hopefully you've already set up your notes for Cornell Notes. Today's objective is written on the board. If you haven't copied that down, go ahead and do that. And you can title today's notes Volume of Prisms and Cylinders. I'll remind you if I get ahead of you so that I'm going too fast and you need more time to copy down the notes, please let our substitute teacher know, and he or she will pause the video so you can keep up and not get behind. Okay, so let's go ahead and get started. Let's talk a little bit about the idea of volume. So the last time we had class we talked about surface area, and that's pretty much just the area that's on the very surface, all the surface of our three-dimensional object. Okay, kind of like if we got out some scissors and cut off all the polygons that are the faces of our polyhedron and kind of laid them all flat and counted up the area. That's what surface area is. Volume, however, is something completely different. Okay, and of course we only get volume when we have a three-dimensional object. So here's the definition for volume. You should copy it down in your notes. It says volume is the amount of three-dimensional space inside a solid. In fact, I'll point out to you that we measure area in squares, but when we're talking about actual space, we start measuring it in cubes because they take up a volume, they take up space. Okay, so it's measured in cubic units. So we're basically going to be counting up how many cubes of whatever size we're talking about fit inside of the solid that we're working with. Okay, so we're used to our answers being like for area, I don't know, 11 inches squared or meters squared. Well, now when we're measuring volume, since we're counting up the number of cubes inside of our solid, it will be measured in cubic meters or cubic inches. Sometimes we even write out the word cubic inches. You can write it either way. Probably most of the time it's easier to just write something like inches with the power of 3 on them because it's faster. So you're welcome to do that with all of your answers today. And I guess, like always, if they don't actually provide you with units like inches or centimeters or feet, you can always use the generic word unit. So you could write units cubed, something like that. Okay, and we're going to be talking about, something having 14 cubic meters. Well, what really does a cubic meter look like? Well, if I was in class, and obviously I'm not, that's why we're doing this video, I have a meter stick. It's about like a yardstick, about 3 feet long. A cubic meter would be like a big cardboard box that is 1 meter tall, like 3 feet tall, and 1 meter wide and 1 meter deep. So, like almost as big as your washer or dryer at your house. That's how big a cubic meter is. So if we said something has 12 cubic meters of volume, that means 12 boxes of that size would fit inside of it. Okay, and here's a quick little question. I actually don't need you to write this one down. Can you take the volume of a hexagon? And the answer would be no. And why couldn't you take the volume of a hexagon? Well, a hexagon is what? A two-dimensional flat figure. Does it have any volume? Are there any cubes that would fit on a flat plane figure? The answer is no. So obviously that's why we've never talked about volume before. All the geometry we've done so far has been flat, two-dimensional, and now that we're talking about three-dimensional geometry, this is the first time that volume even exists. Alright, another thing that we talked about last time we had class was the idea of a polyhedron, which is a type of solid that's built only out of segments. We're going to first start today by describing something called a prism. So if you'll go ahead and write that question down, what is a prism? Prism is a type of polyhedron. So you already know it's going to be built only out of segments, but it's a little bit more detailed than that. And you need to be able to recognize when a polyhedron is a prism, because that will help us do our volume problems today. So first of all, to build a prism, you can start with any polygon you want. You can start with a triangle, you can start with a pentagon, you could start with a dodecagon. Any polygon you want, as long as it's a polygon made out only of segments. Okay, and so if you'll go ahead and draw that I made it pink. Yours obviously will just be drawn in pencil. Go ahead and draw that polygon. Does anyone notice what kind of polygon that is? That is a hexagon. Okay, and that polygon that you start with to build your prism gets called the base. And we've used things called bases before, like triangles have bases. We use them to find area. Well, when we're talking about the base of a prism, you'll notice that they capitalize the letter B. Okay, so it kind of gets subtle, and I actually try to stay away from just making you notice when it's a capital B and when it's not. But if you do notice a capital B, it's not a segment, it's an actual polygon. So it has an area. That's what the kind of base is in a prism. Okay, so that's what we start with, our polygon, and we're going to call it the base. Okay, and then what happens is you take whatever base you're starting with, you make an exact copy of this, in our case, the hexagon, and we move it straight up. So if you'll go ahead and draw that exact hexagon right up above of the first hexagon. Okay, and once we've done this, by the way, that second hexagon or square or triangle, whatever it is that you're using as your base, it is also called the base. So all prisms, and this is kind of important, all prisms have two exactly congruent matching bases. Okay, and I bet you notice we've got like 6 vertices down here. We've got the same exact 6 vertices up here. What do we do to get a prism? Well, basically, all we do is connect each one of those corresponding vertices. So connect the corresponding vertices, and we simply draw it up just like that, and that gets us a prism. And every prism is built the same way. You might start off with triangles, you might start off with decagons or squares or rectangles or trapezoids, but you just start with one, make a copy, and connect all the corresponding vertices. That's how every prism is built. Okay, well, the 2 hexagons in our case, or they could have been squares, are called bases. How about these shapes that are on the side? Do they have a name? Well, they sure are. Those polygons that aren't the bases are called lateral faces. And if someone is noticing and thinking about it, I bet you can tell me what the lateral faces in all prisms, what shape they always are. They are always rectangles. Always rectangles. Okay? All right. Okay, before I show you the formula for finding the area of a prism, I'd like to kind of give you an idea of how volume is calculated. I think if you can get it into your mind how we're actually counting up the amount of three-dimensional space inside of our prism, it will be a lot easier for you to remember the formula. You won't really have to just memorize it, it will kind of make sense to you. And the idea I want to share with you for counting up volume is the idea of stacked coins, which you can see. And by the way, you don't have to write this on your math notebook. I'd just like you to think about this idea. So stacked coins aren't exactly like a prism because they're round, but it's kind of a good idea anyway. You'll notice, like, if we just had one stacked coin, it would be kind of flat. And if we kind of just calculated the amount of area there, we would know how much flat space. So how do we get volume? Well, do you notice if we kind of stack coins, it kind of gets taller and taller and taller? Kind of like a prism can start with some polygon, and then based on how long those rectangles are, you get either a taller or shorter prism. And obviously, if you have a taller prism, it has more space inside of it. So it's kind of like we're stacking up that polygon over and over and over again. So how much volume do we get? Well, basically, it's going to be just the area of the base, and then as you stack it up, you're basically counting up how tall it is, right? So if you find the area of the base and just count up how tall the thing is, doesn't that count up just how much space is inside the figure? And it doesn't leave any gaps at all, so you count all of it up. That's the idea that we're going to be working with. So here comes the formula for the volume of a prism. This is probably the most important idea of the day, so make sure you pay a lot of attention to it. And the formula for finding the volume of a prism, how much space is inside, is this right here. There you go. To find the volume of a prism, you just take the area of the base, and kind of like we're stacking coins, you multiply that by the height of the prism, which is the distance between the two bases. Maybe we should write that down. So this is, the height is the distance between the matching bases in a prism. And we know that all prisms have a pair of exact matching bases. Okay, so you're basically counting up how tall the rectangles are, those lateral faces. Area of the base times the height. Now, I will point out to you that this gets a little tricky because how about the area of the base? Well, what if the base is a rectangle? How would you find the area of it? You do length times width, right? Well, that's great, but what if the area, or what if the base of your prism was a triangle? Could that even be a triangle? Yeah, you could have an area of the base of a prism be a triangle. So how would you calculate that area? Well, a triangle, the formula is base times height divided by 2. So you kind of just have to pay attention to what the base is, and on your own you have to like match it with the correct area formula that goes with that. Alright, let's go ahead and try a problem. So if you will please draw this in your math notebook. Okay, and in some ways this right here is a rectangular prism. In some ways it's the easiest one, but in other cases it's a little bit tricky to figure out. And here's why. On most prisms it's pretty obvious which face is the base. In a rectangular prism, because every face that's across from the other face matches, here's where it gets a little weird. You could kind of consider any of those faces the base. Okay, so that can get a little bit confusing. Okay, so here's what I'm going to do. What I would like you to do every time you do a prism is to identify the base that you're going to be using. And so I'd like you to take your pencil and just mark up what we're going to be using as the base. So the volume formula for this one is what? Area of the base times the height. And what is the base? It's a rectangle. So what formula will I use? Length times width, right? So what is the length and width of what I'm going to be using as the base? It is 7 by 5. Okay, then I'm going to multiply by the height of this thing. And remember, the height is pretty much the distance just between the top base and the bottom base. So what is that distance? And I would like you to take your pencil every time. It's kind of like we're stacking that rectangle right there. So how tall is this thing? How much distance between my two matching bases? 3. Okay, so I work this out and I'll know exactly how much three-dimensional space in centimeters cubed we've got here. So what is 7 times 5? That comes out to be 35. Times 3 more, that would be, let's see, that's 90 plus 15. That comes out to be 105. And because it is volume, we would say centimeters cubed. Okay, so there's our formula. Area of the base, which is a polygon, times the height, which is the distance between the two matching bases. Let's try another problem. How about this one right here? Okay. Alright, first off we should figure out if this is a prism, who is its base. And I'm going to say, maybe I should give you a little more time to draw this one. Remember, you can pick any base that you want. In fact, this might seem a little weird, but I'm going to pick this one because it matches with the rectangle that's over here. I'm going to say that those are my bases. Okay, it might seem kind of weird that I'm not picking bases that are like on the bottom, but that's not what's going on with the prism. To be a base, they just have to match with the thing that's across from them. And like I said, it's a little tricky with a rectangular prism because any of the faces could be the base. Okay, so here we go. What is the volume formula? It is the area of the base. What is the base this time? It is a rectangle. And remember, I would like you to highlight which face you're using as the base. So it's going to be length times width, and then we're going to multiply by our height. Okay, so the length and width would be what? This is 4. And how tall is this thing? It is 2. 4 by 2. Okay, and now I'm going to highlight my height, which is really the distance between my two matching bases. And what is that distance? It's 20. Area of the base times the height, kind of like we're stacking up coins, or maybe this one would look like stacking up like saltine crackers or something like that, if you've ever seen those. All right, 4 times 2, what do we get? We get 8 times 20, so that gives me how much? 160 inches cubed. Okay? Now some of you might notice that there's kind of a faster way to do this. You could just like multiply all 3 numbers together, and would you get the right answer? You would, but it's more important that you understand how the volume of a prism is calculated, even though there might be an even faster way. If you can understand the idea, that will take you farther than just memorizing like a quick little formula that only works for one kind of prism. Okay, so once again, area of the base times the height. Let's try another problem. All right, would you please draw this one on your math notebook? Okay, and this one is not a rectangular prism. Does anyone notice what the 2 exact matching bases are that are connected with rectangles? Well, while you're drawing this one, I would like you to notice that the matching bases this time are these triangles right here, right? This is a base, and it matches exactly with this one right here. Okay, and is this triangular prism laying on one of its bases? Nope, it's kind of like tipped over and laying on one of its lateral faces. You'll notice all 3 lateral faces are rectangles like they're supposed to be. Okay, all right, so hopefully you've had enough time to draw that one. Remember, remind the teacher to pause if I'm start going too fast. Let's find the volume is equal to what? Area of my base times the height, which is really just the distance between my 2 matching bases. So how about the area of the base this time? What shape is that? Well, it's a triangle. So hold on. The volume is going to equal, what formula should I use? Well, shouldn't it be base of the triangle times height all over 2, and then we'll multiply by the height, actually I'm going to take that out, by the height of our prism. Okay, so if I'm just going to look at the polygon that's the triangle, that's the base of my prism, it's what, 6 by 8? 6 by 8 base times height, all divided by 2. And how about the height of the actual prism, which is the distance between the 2 matching bases? How far is that? It's 11. Okay, all my numbers are plugged in. Let's just crunch the numbers. So what is 6 times 8? Isn't that 48? And 48 divided by 2 is 24 times 11. All right, so this will find out how much space is right there if we just do 24 times 11. And let's see, 1 times 4 is 4, 1 times 2 is 2. Put my 0 down, 4, 2, and add it all up, 4, 6, 2. So the volume of this triangular prism is 264, and what would my units be? There they are right there. Feet squared or feet cubed? This would be feet cubed. Okay, we have one last problem to try, and then we're going to switch to a different 3-dimensional solid. Okay, so here is our last figure right here, and then we'll switch to the other thing we have to study today. Okay, this one says find the volume of a solid. Now, is this one even a prism? Well, does it have 2 exact matching bases that are connected with rectangles? Well, if you think about it, this thing right here, going all the way around, it is a polyhedron because these are all segments. Wouldn't this funky shape right here have its matching buddy on the other side? And what's the height of this prism going to be? Isn't the distance between those 2 matching bases that distance right there? Okay, so we can still use, this is a prism, and we can still use our volume is equal to area of the base times the height, which is the distance between those 2 matching bases, and that means we need to work on the area of this base. Okay, and I think I'll remind you, when we have shapes like this, we want to cut them basically into 2 separate rectangles. So I am going to cut it into this rectangle right here, and this rectangle right here. Okay, so really this kind of turned into an area problem until we multiply by the height. And I'm going to make a little edit right here. Let's change that to a 3. So I'm probably realizing I didn't give you enough time to draw that. So anyway, hopefully you've caught up and have drawn that. Once again, have the teacher pause it if you need more time. Okay, so what we need to do is find the area of our base, which is made out of these two rectangles. You could have cut this differently, by the way, so however you want to form your rectangles is fine. However, it is the case that we do need to make sure we get the dimensions of our actual rectangle. So how about the pink one? Well, it's 8 by, and what is this distance right here? It's 2. So 8 times 2 gives us how much area? 16. And now I need to find the area of this one. Now be careful. Is from here to here the 10? No, that is not the 10. The 10 is from all the way over here. So if this whole thing is 10, and this part right here is 2, what do I need to know about this green part? How far is it from here to here? It would definitely be 8. Okay? And how about the height of the green rectangle? Well, how tall is it? Is it 6? Or excuse me, is it 8? Well, 8 is from where? Here all the way down to here. And what should I notice about this part right here? It's 2. So if this whole part is 8 and this part is 2, how much from here down to here? Wouldn't this distance be 6 so that it adds up to the 8? So how much area do I have in this green rectangle? Well, 6 by 8 means we have how much? 48. And how will I get the total amount of area? Well, won't I just take the 48 and the 16 and add them up, and that will give me the area of that total base. And let's see, 48 plus 16 comes out to be, that's 14, 64 units. They didn't give me any centimeters or inches. 64 units squared, because we are talking about area. Alright, so now we can work on the volume of this thing. So what does volume equal? The area of the base. Well, didn't I just work that out? It's 64 times the height, which is my distance between my two matching bases. It's kind of like we're going to stack up this L-shaped figure over the course of how many units? 3. 64 times 3. Alright, let's work out 64 times 3 and we'll have our answer. 12, carry my 1, 18 plus 1 more is 19. The volume of this prism is 192, and it would be what? Units cubed. There is our answer. Okay, we've got one thing left to study. We've just done prisms, and now we're going to talk about something called a cylinder. So you don't have to write this down, but we're going to jump right into the volume of a cylinder. Can you see that cylinders and prisms have a lot in common? Just like prisms, cylinders have two bases, and they're kind of connected by just drawing straight up. Do you notice what the base of a cylinder always is? Well, it's a circle. So actually, cylinders are really easy to work with. Instead of the base being a triangle or a rectangle or that weird L-shaped looking figure, our base is always a circle, and that makes cylinders very predictable. Okay? Alright, so we're going to go right into the area formula for a prism, and this time the coins really make sense because they make a cylinder. So how do you find the volume of a cylinder? Well, you just take the area of the base and multiply by the height. It's the same formula as for a prism, except we always know what the base is. It's a circle. So if you find the area of the circle, that's the base of your cylinder, and multiply by the height, here's what I just said, you get the volume of the cylinder. Okay, so right there, area of a circle. There's nothing tricky about this. Area of the circle. And we will be working with exact volume, which means, are we going to multiply by 3.14, or are we going to leave the symbol for pi in our answer? Well, exact, we use the pi symbol, right? If you use 3.14, why is that not exact? Well, pi is not exactly 3.14. Okay, so let's try. I think we're just going to do two problems here. So here comes our very first problem. Okay, so if you'll please draw this one in your math notebook. And we are going to find the volume of this cylinder. By the way, I'll ask you this while you're drawing the figure. Are cylinders polyhedra? And of course they're not, right? They definitely have curves in them. So these are just solids, not polyhedra, but that's okay. It's just not a polyhedron. Okay, so what was that volume formula? Area of the base, which is what? A circle. So what's that formula? Pi times the radius squared times the height, which remember, the height is always going to be the distance between the two matching bases. So times height. Okay, let's see if we can fill some stuff in. Pi times the radius squared times the height. And what would my radius be? Well, very clearly the radius for the circle is 2. And how about the height? What is the distance between those two exact matching circles? It's 5. All right, now that those are filled in, we just need to work out what the answer is. So volume is equal to pi. First thing we'll do is square our number. So what is 2 squared? That would be 2 times another 2, which would give me 4 times 5. And what is 4 pi times 5? We get a volume of 20 pi inches cubed, which is our answer. You'll notice that working with cylinders is really pretty easy. Okay, and just in case you forgot this, that pi sometimes weirds some students out. What number is it basically? 3. So how much is 20 pi? It's about 60 inches cubed. Okay, would fit inside of this can of soda? I don't know. All right, let's try just one more problem. Let's take a look at this one right here. Would you please write this one in your math notebook? Okay, we're working on volume, and all that's going to be is what? The area of the base, and like we're stacking coins, times the height. And that will totally fill up this, what looks like kind of like a tank, and tell us exactly how much three-dimensional space is inside of there. Okay, so volume equals area of the base, but with a circle it's always the same formula. Pi times the radius squared times how tall is it times the height, the distance between the two matching bases. Okay, so let's rewrite this and leave some gaps for our variables. Okay, in here goes our radius, and what is our radius this time? The radius of our circle is 3. And how tall is this? The distance between those two matching circles is also 3. All right, let's do some math. Volume equals pi times, what is 3 squared? Remember, it's not 3 times 2. What is it? 3 times 3. So 3 squared comes out to be 9 times 3. And 9 pi times 3 gives us a volume of 27 pi feet cubed. All right, we are done taking notes. The teacher will now pass out your assignment that will give you some practice with this. Do your best to understand the idea of volume and not just memorizing some formula that gets you the answer. Okay, we're trying to count up the amount of three-dimensional space inside these figures, and if you can kind of grasp the idea of how we're doing it, these problems will make a lot more sense to you. All right, you'll have some time in class to work on the assignment. What you don't finish turns into homework that will be due the next time we have class.